Hey everyone, welcome back to POL 935. And this week is our first R workshop where we're going to talk about the Tidyverse. So first I want to give you a brief overview of the videos that I will post this week. In this first video, I'm going to talk briefly about why we're using R in the first place, and specifically why we want to focus on the Tidyverse for a lot of the data cleaning tasks that we will encounter throughout the course. Then, in the next video, I will talk about data visualization, specifically with ggplot2. And I will just briefly talk about this package because we will have a whole workshop focused on data visualization using ggplot2 later in the semester. The next video will be about data transformation, and the workhorse for data transformation in the Tidyverse is dplyr. So we're going to talk a little bit about the different functions that are available there. And then we will talk about packages, different packages to import different types of data sets into R using readr and other related packages. Then more generally, I'm going to talk about tidy data and how we can get messy data into a format that we actually want to analyze using some functions that are in the tidyr package. And that's all. So let me briefly talk about why we're going to use R in this course, and specifically why we want to focus on the Tidyverse. So there are a couple of really good reasons to use R, and I know that some of you already have some experience with it. But just briefly, one big reason why R is great is that it's free and it's open source. So there's a broad user base and a lot of new developments, new packages are directly implemented in R. So you have access to a lot of the new state-of-the-art statistics. You also have impressive visualization capabilities with ggplot2, as we will find out today, but also in base R. Overall, it's also faster and more efficient than a lot of other commercial statistical packages like Stata and SPSS or SAS. Or others that you might have encountered in the past. And most importantly for this course is that R is ultimately a fully fledged programming language that can interface with other powerful languages, for example, Python or C++. So especially if you have more complex computational tasks, this will be incredibly useful. So for some of you who have used, for example, Stata before, one important difference in how you think about R as compared to, for example, Stata, is that the way you were using Stata was in a pretty linear fashion. You had a single data set, like a survey or something like that, and then you use Stata to kind of analyze that survey and run some form of analysis, maybe a regression model, right? And R is a lot more flexible in that it doesn't only work with one single data set as the basis for all the computations, but it can contain a lot of different objects in its workspace. And these objects can be, for example, data that we scrape from Facebook or Google Maps data, or, for example, a traditional survey data spreadsheet. But those can all be combined as different objects, and we can, for example, run some text analysis or network analysis, and that ultimately then leads to a regression model or some kind of output that we then want to communicate. So overall, R can handle a lot of different objects at the same time in one workspace, and that gives it a lot more flexibility compared to other statistical packages like, for example, Stata that you might have used in the past. So after talking about R in general, why do we want to focus on the Tidyverse? And you've read or at least for this week, you're assigned to read some chapters in the R for Data Science book. And the way they kind of describe the different steps that are typical for any data science project are displayed here. So we always start with importing some external source of data that is usually messy, that is in a format that we can't directly analyze. We need to tidy that data, bring it into a format, and I'm going to talk about what tidying the data ultimately means a little bit more. But ultimately, we want to bring it into a format that we can analyze. Then we have to make some transformation. We want to visualize the data, the transformed data, We want to run some models. Based on that models and that understanding, we might, perform other transformations and go through that process. And ultimately, we will end up with some results that we want to communicate to others. And the point is that the Tidyverse provides a lot of very useful tools to facilitate each of these steps. And I'm going to talk about a lot of these kind of initial steps in the data science project today or this week, right? So it's not the case that the things that we're doing now with these Tidyverse packages you can't do with base R. It's just a different way of kind of thinking about the problem, and it makes a lot of the steps that you have to go through a lot easier. So if you have used R before, and specifically if you have used basic R before, some of the things will seem a little bit different and maybe require a little bit of rethinking, but ultimately you will learn a set of tools that will make a lot of the kind of standard tasks of getting your data ready for analysis a lot easier, a lot simpler. One of the things that you see with with code that is using the Tidyverse is the pipe operator. The pipe operator is this percent larger percent in R. And this is a really useful operator that makes a lot of coding tasks, especially data transformation tasks, a lot easier. And so because the code in the following videos will all use the pipe operator, I just want to briefly talk about what exactly it does. And ultimately what it does, or maybe let me start with an example of base R. And this is now kind of a toy code example. Specifically, this code describes in base R how a morning might look like. If you look at this code, it starts with leave the house, get dressed, get out of bed, wake up, me, right? And so if you want to understand this code in base R, you kind of have to go from the inside to the outside. We start with me, the object here, and then the first function, maybe I can show this here. The first function that is applied is waking up. Then the next function is getting out of bed, and so on until leaving the house, right? So in order to understand what is going on with the first object, which is me in this case, we kind of have to start at the start at the center and work our way backwards. And so it can be sometimes really difficult to understand what is actually going on in code because it's all nested within each other. More importantly, if we have additional arguments for specific functions, these arguments have to be included, and it's not directly obvious which function this argument belongs to. So for example, here we have this argument jacket is equal true, which of course is part of the is an argument for the get dressed function, but without kind of counting the parentheses, we're not quite sure exactly what this argument belongs to, right? So obviously this is kind of a stupid toy example, but it makes very obvious why the pipe operator is so useful. Because this is how mornings look like using the pipe. We start with the object that initially we want to transform, or that we want to run some computation with. The next operation is then wake up. Then we get out of bed. Then we get dressed. Here is now the argument jacket is equal to true. And then we leave the house, right? So it's the same set of operations. They're just reordered kind of chronologically. So what does the pipe operator do? All the pipe operator does is it takes an object that is to the left of the pipe operator, and it kind of pipes it or inserts it as the first argument into the next function. So me is piped into wake up as the first argument, and then wake up, this function has an output as well. And that output is then piped into the next function, get out of bed. And that output of that function is then piped into the next function. Okay. So of course this is kind of just a silly toy example to give you an idea of what is meant with the pipe, or what the pipe does. And in the next video, or the one after that, we will start actually using it with actual R code. Of course, it can be tedious to type the pipe operator every time. So there is a shortcut in RStudio and in RStudio Cloud, which is for Mac users Shift Command M, and for Windows users Shift Control M to insert the pipe operator. All right, so those were all kind of the preliminaries. The next couple of videos are going to be focused straight on discuss each of these individual packages in the Tidyverse. I just want to finish with a brief set of to-dos for you for this week. So all these should be completed by before our next meeting, our next Q&A session, which is on September 9th. The first thing that's in the syllabus is read Wickham and Grollmund 2016 and skim chapters 1 through 12 if you use the online version of that book, or chapters 1 through 10 if you're using the printed copy. And so if you look at that book, it sounds like a lot of chapters, but depending on your background in R, you can kind of go through some of those chapters fairly quickly. And a lot of the code and a lot of the examples that I'm showing in the videos that will follow this week are straight from that book. And so it'll be a quick and easy read. The next thing you can do is you can work through the code for this session, so for the coming videos on RStudio Cloud. And I'm going to just I have to switch into a different browser. The way this looks on RStudio Cloud is it should look something like this in our shared workspace. And if you want to follow with the code that I'm going to show in this in the following videos, you can just click on this project, and hopefully after not so much time, you will see a copy of the entire code base for the videos that I'm going to post this week. Unfortunately, this is going to take a little bit, so I'm going to switch back to the presentation and then check in a second. You can also check out the Tidyverse cookbook. This is a book that I didn't mention in the syllabus, but this is a nice document that provides code examples for a lot of Tidyverse related problems or questions that you might have. And then you can start working on assignment 1, which is posted on Canvas and on RStudio Cloud. And I'm going to switch back to RStudio Cloud to see whether the project is loaded. All right, so the project is loaded. That's good. If you click here on tidyverse.r, I'm jumping ahead a little bit, but you'll see a lot of the code that I will use in the slides for this, in the presentations for this week, and also the data. So if you just copy this project, you'll be able to follow along. Lastly, if you want to get started on the problem set, you can also click on that problem set, and you'll see an R Markdown document with the assignment. And you can basically create your own copy of that problem set and then start working on the assignment as well. All right, so that's it. I'm going to start with our discussion of ggplot2 in the next video.